Which is the right major for you? Software or chemical engineering? This is what we will be talking about today, but before we get started, please don't forget to smash the bell and subscribe button so you don't miss out on any future content just like this that are going to lead you to success. Obviously, there's no right or wrong answer when it comes to what our passion is, but a lot of the times that might be an unknown until a later stage in our life. So it's important to understand all the implications that come with choosing a specific major. Software and chemical engineering are two of the main branches of engineering, and I gotta admit that both seem like attractive majors on paper.
But let's dive deeper into the curriculum, job outlook, salary, and prestige to see if these majors are really as attractive as they appear to be, so you can make an educated decision for yourself and not have any regrets about dropping 100 grand on the wrong degree after college. Let's start off with an easy question. If you've taken algebra, geometry, calculus, and linear algebra in high school, try to remember if you enjoyed solving math problems. If your answer is yes, and designing social media programs, web pages like YouTube, as well as programs that make your computer and smartphone function properly, then software engineering is likely right for you. On the flip side, if math is not really your thing, but you enjoy chemistry in high school more, specifically related to the structure and reactivity of molecules, different types of reactions, as well as all of the different labs that you did like pH measurement, chromatography, and spectroscopy, then chemical engineering is likely right for you. Again, this is just a preliminary evaluation to at least point you in the right direction of either of the two engineering disciplines.
Now, in order to determine if software or chemical engineering is a better fit for you, we must first know exactly what these two things are. So what in the world is software engineering?
It's ranked as one of the hottest disciplines and is a branch of computer science that involves writing and building code using different programming languages, testing and debugging code, and solving problems that arise in production to improve existing products using math, engineering analysis, and design principles. Software engineers are the creators behind the software and embedded systems and digital products such as Gmail, Google Chrome, Facebook, Android, iOS, Windows, just to name a few. As a software engineer, you will be able to work in essentially every industry, including but not limited to aerospace, automotive, food, medical, consumer electronics, defense, finance, and manufacturing.
Now let's talk about chemical engineering. What in the world is that?
It's a specialized discipline encompassing the translation of molecular information into the creation and manufacturing of new processes and products such as plastics, dyes, drugs, fertilizers, petrochemicals, food, and even the development of clean energy sources. As a chemical engineer, it all starts with their foundational knowledge in chemistry, biology, physics, and math to create innovative solutions to important industrial and societal problems in a plethora of industries, including healthcare, energy, environmental, electronics, advanced materials, biotechnology, construction, food, defense, and chemical process.
Now that you have a high-level understanding of these two disciplines, how does the curriculum for these two majors stack up against each other?
As you probably can guess, both software and chemical engineering students take the general set of engineering core courses during their freshman and sophomore year, like math, which includes calculus 1 and 2, multivariate calculus, differential equations, statistics, linear algebra, physics 1, which is mechanics, and physics 2, which is electricity and magnetism, as well as basic chemistry. Moving on to the common engineering courses between these two majors, you will have to take programming with a common language such as MATLAB or Python for solving engineering problems, and an introductory design course intended to build a problem-solving mindset, computer skills, and familiarity with elements of engineering design. From this point on, the courses between these two majors will begin to diverge and become more specialized. Before we talk about the software engineering curriculum, it's worth mentioning that not many universities offer a software engineering degree for undergraduates, and computer science degrees are more widely available, but both are equally good for landing a software engineering job. So as a software engineering or CS major, you'll take computation structures that introduces the design of digital systems, and computer architecture covering topics like combinational and sequential circuits, and instruction set abstraction for programmable hardware, which just means code that tells your computer CPU what to do. Then there's introduction to algorithms that teaches common algorithms and data structures used to solve computational problems within a programming context, and various ways to measure algorithm performance. Next is fundamentals of programming, covering programming and Python basics, algorithmic analytic techniques, data types, and recursion. You also have to take elements of software construction that teaches you how to write software that is safe from bugs, easy to understand, and can be easily changed. Some topics include invariants, design patterns for object-oriented programming, and concurrent as well as functional programming. Another course you will take is Computer Systems Engineering, covering computer software and hardware systems, including modular programming, operating systems, computer networks, naming conventions, and computer security and privacy. Then there is AI, or Intro to Machine Learning. This class will introduce representations, methods, and architectures used to build applications and to account for human intelligence from a computational point of view. You will learn how to use different learning methods like identification trees, neural networks, and support vector machines to solve problems. You will also likely have to take a more advanced algorithms class called Design and Analysis of Algorithms that teaches how to create efficient algorithms covering topics like sorting, search trees, heaps, hashing, divide and conquer, dynamic programming, greedy algorithms,
Bro, what are you talking about, man?
amortized analysis, and graph algorithms. Another class that most programs will require is Intro to Electrical Engineering and Computer Science, where you apply both electrical engineering and computer science principles as a team to design an electromechanical system, such as a robot or internet-connected wearable device, or perform in-depth experiments to better understand cellular phone networks and other communication systems.
So as a chemical engineering major, you will have to take a lot of chemistry related courses. In addition to general chemistry, you'll have to take 1 or 2 organic chemistry and inorganic chemistry courses, as well as a general biochemistry course. Also expect to take a basic thermodynamics class introducing state variables, work, heat, entropy, and free energy, as well as a chemical and biological engineering thermodynamics class focusing on thermodynamics of multi-component, multi-phase chemical and biological systems. You probably already know that chemical engineering is very hands-on, so you will for sure be taking a project-based class where you work in teams on a project and applied chemical engineering research suggested by local industry. For example, if your team was interested in polymer science, a potential project idea could be characterizing the physical properties of natural and silicone rubber. More advanced courses that you would take as a junior and senior include separation processes, chemical kinetics and reactor design, and integrated chemical engineering that presents and solves chemical engineering problems in an industrial context such as process design and dynamics.
So the question to ask yourself is, are you more interested in developing and debugging code and algorithms for embedded systems in, say, a Tesla Model X or Boeing 777, and for digital products such as the Facebook app, operating systems, and computer software? Or are you more interested in chemical process design and improvement, like designing reactors with the appropriate flow rate, volume, pressure, and temperature to maximize the production of a certain chemical while minimizing waste, energy consumption, water usage, and depletion of non-renewable raw materials?
So now that we have a good sense of the curriculum, let's compare the annual salaries and see what the current and future job outlook looks like for these two types of engineers.
Let's begin with the salary breakdown for software engineers. We see that the median base salary is $110,140, while the lowest 10% and highest 10% made $65,200 and $170,100. Obviously, things like years of experience and work location will contribute to this salary gap, so someone with 10 plus years experience working at Google or Facebook in California or New York would probably be amongst the top 5% of earners. The number of jobs in 2020 was 1,847,900 and is expected to see a whopping 22% increase in jobs between 2020 and 2030, which is just off the charts compared to the overall engineering field. Now moving on to chemical engineering, we see that the median salary is $108,540, while the lowest 10% and highest 10% made $68,430 and $168,960 respectively, and the median salary of software and chemical engineers is essentially the same. The total number of available chemical engineering jobs in 2020 was 26,300, which is almost 70 times less than the available number of software engineering jobs, so job security is not great for chemical engineers. It's expected to see a 9% increase in job growth between 2020 and 2030, which is slightly above average compared to the overall engineering field of 7%, but a lot less compared to software engineering. Software engineering tops the list both in terms of number of jobs and job growth by a long shot, and job security is something you will not have to worry about.
Aside from the curriculum, salary, and job outlook, the last component we'll look at is prestige. For some people, it's all about the respect. Now, the way I've defined prestige is how well known is the company you work at, and I assume that the larger the company, the more prestige it has. For all intents and purposes, we'll assume that the job title is not correlated with prestige.
Consequently, I have evaluated prestige solely based on the total number of top 100 Fortune 500 companies that offer software and chemical engineering jobs. There was a clear winner, which I'm sure many of you have already guessed, but here are the results. 93 out of the 100 companies offer software engineering jobs, including Walmart, Amazon, Apple, CVS Health, United Health Group, Berkshire Hathaway, Alphabet, McKesson, AmerisourceBergen, Costco, Cigna, AT&T, Microsoft, Cardinal Health, Chevron, Home Depot, Walgreens Boot Alliance, Marathon, Elevance Health, Kroger, Ford, Verizon, General Motors, Centene, Meta, Comcast, Phillips 66, Valero Energy, Dell, Target, Fannie Mae, UPS, Lowe's, Bank of America, Johnson & Johnson, Archer Daniels Midland, FedEx, Humana, Wells Fargo, State Farm, Pfizer, Citigroup, PepsiCo, Intel, Procter & Gamble, General Electric, IBM, MetLife, Prudential, Albertsons, Disney, Energy Transfer, Lockheed Martin, Freddie Mac, Goldman Sachs, Raytheon Technologies, HP, Boeing, Morgan Stanley, HCA Healthcare, AbbVie, Dow, Tesla, Allstate, AIG, Charter Communications, Cisco, Merck, New York Life Insurance, Caterpillar, Cisco Systems, TJ Maxx, Publix Supermarkets, ConocoPhillips, Liberty Mutual Insurance Group, Progressive, Nationwide, Tyson Foods, Bristol Myers Squibb, Nike, Deere, American Express, Abbott Laboratories, StoneX Group, TIAA, Oracle, Thermo Fisher, Coca-Cola, General Dynamics, CHS, USAA, Northwestern Mutual, Nucor, Exelon, and Mass Mutual. By contrast, 35 out of the 100 companies offer chemical engineering jobs, including Apple, ExxonMobil, Ford, GM, Chevron, Dell, Marathon, Johnson & Johnson, General Electric, Intel, Procter & Gamble, PepsiCo, Phillips 66, Lockheed Martin, Valero Energy, Boeing, HP, Raytheon, Merck, Tyson, Pfizer, Caterpillar, Energy Transfer, Dow, General Dynamics, Nike, Northrop Grumman, John Deere, Abbott Laboratories, Exelon, Coca-Cola, Honeywell, Thermo Fisher, 3M, and Tesla. Alright, summarizing everything we talked about. The curriculum for software and chemical engineering are neck and neck in terms of difficulty. What's common between these two majors is the math and engineering problem-solving mindset. While software engineering classes focus on equipping students with effective engineering practices and knowledge of programming languages to build software products, computer games, and run network control systems, chemical engineering classes are geared towards students wishing to gain molecular knowledge for chemical process design and improvement. Moving on to salary, software engineers make slightly more than chemical engineers, where the median salary for software engineers is $110,140, while for chemical engineers, it's $108,540. Obviously, if you work at one of the big tech companies, you will make a lot more, and these numbers are no longer accurate, but in general, they hold true for most companies. Finally, the job security and prestige level that comes with software engineering blows chemical engineering out of the water, so definitely ask yourself if these two things matter to you.
At the end of the day, the goal is to pick a major that you can build a career out of and enjoy doing for a lifetime. There's really no right or wrong answer when it comes to choosing software or chemical engineering. You might be someone who already knows that your dream job is to work at Google as a software engineer to develop their latest and greatest Google Maps features. Or you want to work as a chemical engineer to develop a scalable, stable, and cost-effective biosensor chemical manufacturing process at a big medical company. I think knowing what you want already in college is fantastic, but rarely is this the case, and more often times than not, you won't know exactly what you want until after working several full-time jobs or internships. If this applies to you, then I definitely recommend going with software engineering because it's so high in demand, and the compensation, job security, job growth, and prestige are second to none. Alright, as always, thank you so much for watching, and if you enjoyed this video, please don't forget to like and subscribe, and I'll see you in the next one. Peace.